So now that we focused on graphing and writing exponential functions, we're now going to focus on writing exponential functions for word problems. So as we write these equations, it's pretty much going to have the same form as an exponential function, but since we're interpreting it in terms of a word problem, we have to be familiar with some initial vocabulary. So our a value is still going to be our y-intercept. That is still going to be what's happening when x is 0. But oftentimes we'll refer to this in a word problem to be the initial amount. What is happening when x is 0? So that's still going to be our a value. Then from here, our b value is going to be called our rate of growth or decay, which is still our multiplier. It's still what's happening as time goes by. It's still how we are growing or decreasing, but it's just a different way of saying it. It's going to be the rate of growth or the rate of decay, depending on the particular problem. And then from here, our x value is going to be the time period, how much time has gone past, and this will be something that we'll use to actually evaluate and find an answer. It will actually be used to solve and apply our word problem. So just a refresher as we tackle our first word problem together, our a value is still our y-intercept value, but this is also called our initial amount. And our b value is still our multiplier, but it's also going to be our rate of growth or decay. So as we read through this problem, it says you deposit $200 into a savings account that earns 3% interest compounded yearly. We're going to then write an equation that models this situation. So this $200 that you see here, that's how much money we started with initially. So when they're saying we deposited that money in, and that's our starting value, that is saying that our a value is in fact equal to the $200 that we started with. Then this next piece here says it earns. Earns is telling us that it is growing over time. And it's growing by 3% each year. So essentially what's happening is we have 100% of our money. But it is growing 3% each year. So this percentage right here is meant to help you find, in this case, our rate of growth. So we have 100% of our money, and then we're adding 3% to it each year. So after each year, we really have 103% of our money, which means we have more money than when we started, which is pretty nice. Now, unfortunately, while this is our rate of growth, we can't just plop a percent into a problem. We always have to convert our percent into a decimal, and there are two ways that we can do this. First, you can take 103 and divide it by 100. So we have 1.03. Or you can use the decimal trick and say I'm going to move my decimal 2 to the left to get 1.03. So that is our rate of growth. So this is actually our b value. So now we can go to our equation and we can write down, okay, our equation is y equals our initial value of 200 times our rate of growth, which is 1.03 or 103% to the power of x. So that there is our equation. Then from here, we're going to apply this equation to the situation described in part B. So in part B, it says, find the balance in the account after 7 years. So what this is telling us is that x is equal to 7. And what we need to then do is take our equation. So we have y is equal to 200 times 1.03. And in place of x in that exponent, we are going to write 7. Now if we take our calculators, we're going to type in 200 times 1.03 to the power of, remember this little key, 7. And if we press enter, what we will find is that after 7 years, if we grow at 3% per year, our account will now be worth $245.97. So let's read through example 2. It says a business has $8,000 in profit in 1990. Then the profit increased by 2% each year. So if we take that information that they've provided us with, that $8,000 is again an initial amount. That's how much was initially the amount of profit that they had. So that is our A value, and it's equal to 8,000. Then from here, the second piece of this is we need to find our rate of, in this case, the increase tells us growth. So we have rate of growth. And remember that we always have 100% of what we started with. And here we're increasing that by 2%. So I really have 102% of my profit at the end of each year, which is nice. It means that my profit is increasing over time. So then I need to turn my percent into a decimal value that I can work with. So I'm going to move the decimal over 2 spaces. So we have 1.02. The other way you can figure this out is by taking 102 divided by 100. And if you divide it out, you'll get the decimal equivalent to that percentage. So here what we see is we have a B value of 102. So now we go over to our equation and we substitute. We have y is equal to 8,000 times 1.02 to the power of x. So that's our equation in general. Then if we look at part B, it says predict the profit in 2001. Well, I started in 1990, so 1990 is really times 0, or when x is equal to 0. And what that means is in 2001, x is equal to 11, because 11 years have gone by. So now we're going to take our equation and we're going to substitute in 11. So we have y is equal to 8,000 times 1.02 to the power of 11. And if we plug that in, remember you want to use your caret key, we find that we will then make in profit in 2001 approximately $9,946.99. So our profit has increased by almost $2,000 per year in the past 11 years. In example 3, we're going to encounter our first situation where we actually have a rate of decay. So if we read through here, it says the number of acres of ponderosa pine forest decreased. So that's telling us that we are decaying. Decreased in the western United States from 1963 to 2002 by 2% annually. In 1963, there were 41 million acres of pine forest. So we have to start by writing an equation that models this situation. Well, the first thing I notice is that I had 41 million as my initial amount of trees in 1963. So I'm going to set my A value equal to 41, knowing that my answer is going to be in millions. And then from here, I notice that I am decreasing over time. That's telling me that I'm decaying, and I'm decreasing by 2% each year. So I have a rate of decay, and what's essentially happening is I had 100% of my forest, but I'm losing 2%. So at the end of each year, I only have 98% of my forest remaining. So that's my rate of decay, is 98%. Now, from here, I need to turn this into a decimal to work with. So I'm either going to move the decimal over 2 places and get 0.98, or you can take 98 over 100, and that will give you the 0.98. Regardless, 0.98 is our rate of decay, or our B value. So now we can write our equation. We have y is equal to 41 times 0.98 to the power of x. Now in part B, I'm going to utilize this equation to predict the number of trees in 1973. And note that I started in 1963, so in 1973, 10 years have gone by, or 10 years have passed, so x is equal to 10. So I'm going to substitute that into my equation. So I have y is equal to 41 times 0.98 to the power of x. And I find that I have about 33.5, and remember my answer is in millions, million trees remaining in 1973. And final word problem example, it says, you purchase a cell phone for $250. The value of that cell phone decreases, so this is telling us it decays over time. It decreases monthly by 4%. Write an equation that models the situation. So I can already see right off the bat that my initial value is 250. That's how much it was worth to start. So that's going to be my A value in this problem. Then I can also see that I have a rate of decay, which means that over time, the value of my phone is going down. So I always start with 100% of my worth. And here it's going down by 4%. So I'm going to subtract out 4%, which leaves me with 96%. Now we need to turn 96% into a decimal. So I have 0.96. And remember, if you want to use the trick of 96 over 100 and divide it out to find 0.96, that is okay too. But that 0.96 is our B value. Then from here we can write our equation. So we have y is equal to $250 times 0.96, which is our rate of decay, to the power of x. Then this last piece says to find the amount the cell phone is worth after 2 years. Now, the most common thing that students do incorrectly here is they rush a little bit too much and they say that x is equal to 2. I'm here to tell you right now that in this case, even though it says 2 years, x does not equal 2. Let's go back up and read our original problem. It says you purchase a cell phone for $250. The value of that cell phone decreases monthly by about 4%. So when I say 2 years, this is decreasing by 4% per month. So I got to think about how many months are in 2 years. And hopefully you know that there are 12 months in a year. And we have 2 years. So we have a total of 24 months. So x here is actually equal to 24. So now if I take my equation and I substitute in 24 for x, so I have y equals 250 times 0.96 to the power of 24. If I substitute that in there, what I find is that my phone is worth approximately $93.85. So after 2 years, while it's still worth some money, it's not worth nearly as much as it was worth to start.